Hello everyone. Now we are going to see the numerical problems on work or energy. So first of all, we will see some MCQs, and you can read the question number 1 here. The energy is released in some nuclear reactions, and which nuclear reaction takes place in a nuclear power station, and which nuclear reaction takes place in the sun. So we know that the nuclear reactions are of two types. The first is a nuclear fission, and the second one is called as nuclear fusion. So fusion is a kind of nuclear reaction where the lighter nuclei combine and they form the heavier nucleus, and the fission is the one where the heavier nucleus split and it forms the lighter nuclei. So in the nuclear power station, what kind of reaction takes place? That reaction is nothing but the nuclear fission. Okay? This kind of reaction takes place in the nuclear power station, and in the sun nuclear fusion reaction basically takes place. Okay, so where in the sun the hydrogen atoms they combine to form the uh, helium atom, and in the nuclear power station we know that we are using the uranium, and we are going to do the nuclear fission using the neutron bombarding, and then we are getting some lighter nuclei. Okay, the nuclear reaction you will be learning more in detail in the nuclear block, but for time being just note that in the nuclear power station the fission is there, and in the sun or in all stars nuclear fission is there. So answer, the B option is the answer. The force acts on, the second question, acts on an object and causes the object to move a certain distance in some direction as the force. Okay, so which row represents the situation in which the largest amount of force? So here we want to calculate the largest amount of force, sorry, the largest amount of work is done on the object by the force. So here we need to find out the largest amount of the work. So we know the work is nothing but the force multiplied by the distance in the direction of the force. So it is already given the same direction the distance has as that of the force. So we need to just multiply the things, and by multiplication we can understand which is the highest. So 2, because it force into distance, nothing else. So 2 into 40, the first one you will get about 81, and here 10 into 2, so we'll get here 20. The third one 20 into 6, so we'll get here 120, and the third one we can see here 100 into 1, so we'll get 100. So which is the largest value? So 120 is the largest value, so option number C is the answer. Now the question number 3 here, an object initially at rest is dropped from the height of 12 meter. The change in the gravitational potential energy when it falls to the ground, it's 565 joule, and the frictional forces are negligible, so we are not counting the frictional force. And what is the speed when it hits the ground? So here you can see the scenario. I have attached one image over here. So this object is falling down, so when it is at some particular height, it has only the potential energy, because here at this height the velocity is 0, so kinetic energy is also 0. While falling down, the kinetic energy increases and the potential energy decreases, and when it reaches the ground it has all the kinetic energy, and if I consider the this negligible air resistance, then potential energy will be 0. So this will come out to be 0, because height h will be 0 at the ground, so entire energy will be the kinetic energy. So we are just going to equate, because entire potential energy is converted into the kinetic energy. So I can say the kinetic energy, that is half mv square, will be equal to mgh. Okay, so mgh is nothing but potential energy. So here the potential energy is converted into the kinetic energy, and so those are equal, so we can here cancel m and m here. G value, we know the G value is nothing but, you can take 10. H height is given, that is nothing but 12 meter, so you can put this H is equal to 20 meter, and you can calculate. This is 10, you can consider for G, multiplied by height is 12, that is nothing but half into V square. So no need of mass is cancelled out here, and we can calculate V square. You can make the V square as a subject, and then you can make the V as a subject, and if you calculate value, it will come close to the value of 15.5 meter by second. So answer number B is the option. B is the answer. You have to just make V as a subject and you can calculate. Now the question number 4. Which energy resource does not derive its energy from the sun? So we know the sun is the supreme source of energy, and it actually gives the energy and that converts into different forms. But here in the options, the hydroelectric, nuclear fission, waves and wind, only the nuclear fission is the one which does not derive its energy from the sun, because it's the nuclear energy and that is coming from the mass of the nucleus itself. So we know that in the nuclear fission, the splitting of the nucleus occurs and it does not require any external energy because it is a nuclear phenomenon. And waves are the result of the energy coming from sun. Wind is also the result coming from the sun's heat. So all these are not options. So option number B is only the option which does not derive its energy from the sun. Now the last question, you can see here the diagram represents the energy transfer for a device. So this is our input energy, and some amount of energy is a useful energy and remaining amount of energy will be wasted. And redrive has a 50% efficiency. So what equation is correct? Which equation is correct? So 50% efficiency, the efficiency I have written over here. Efficiency is useful energy and the useful energy output divided by energy input, and you have to multiply 100 to get the percentage here. So here 50% is device efficient, that means 50% we are getting as a useful output and remaining 50% will be wasted. Remaining 50% will be the wasted one. So that means useful output energy must be equal to wasted output energy divided by 2. Okay. So you can see from here also the efficiency is 50%. So 50% is nothing but that is equal to 0.5, and 0.5 is nothing but 1 by 2. So I can write down here 1 by 2. So 1 by 2 is equal to useful energy output divided by the energy input. So we can say that useful energy output is nothing but wasted output energy divided by 2. So option number B is the correct one. So here you are just simply using the efficiency formula and nothing else. So we are going to end our MCQs here, and now we will see the structure problems. So now we will see the first question in the structure problem. So you can see here this figure 2.1 shows a conveyor belt transporting a package to the raised platform, and the belt is driven by the motor. So here you can see the package is kept over the belt, and this is a motor and it is continuously rotating, and so that the package will be going to the this platform, raised platform. The mass of the package is given, that is a 36 kg. Calculate the increase in the gravitational potential energy of the package when it is raised to the vertical height of 2.4 meter. So this vertical height, right, it is starting from this point and it is going to this point, and the vertical height, this vertical height, basically that height is given, that is 2.4 meter. So we want to calculate the increase in the gravitational potential energy, and we know what is the formula for the gravitational potential energy. All the formula I have written over here, the potential energy, kinetic energy, work and the power, etc. So the gravitational potential energy is nothing but, we know that formula is nothing but mgh, and here the value of the mass is given, that is nothing but 36 kg. So multiplied by g value, we take 10 for your simplification. Height, that is 2.4, it is already given. So we are getting roughly the value over here is nothing but around 864 joule. 864 joule value is coming out to. So 2 or 3 significant figures are okay. So 864 joule I will write down here again, so that you will get the full marks. If you forget